Hi there, my name is Shannon Witten. I'm a Red Seal carpenter and instructor here at the College of Carpenters and Allied Trades. And this video is to go over my geometry classes review before their exam. Now we'll be doing this in class, but I hand it out early in the hopes that my students will start to take a look at it. For some that can be a little daunting because the instructions, aren't necessarily what we look at during our assignments. So for anybody here, welcome. Thank you for trying to get ahead on it. And if you want, you can mute me and just follow the steps of the compass. If you want to listen, I explain it a little bit as we go. And if you want to pause, rewind, fast forward, that is all good, because I'm just going to be going through the review sentence by sentence. So, very first sentence says scale 3/4 equals 1 foot. So I'm going to be using my 3/4 inch scale. And I'm going to be going through that sentence by sentence, even though I have little bullet points that lumps a few together. So the very first sentence is construct a square with 5 foot 6 inch sides. So I'm going to start my baseline about 3 inches up my page, because I'm going to need space all the way around this square by the time I'm done, and I will on my exam as well. And without going too into all the different geometric principles like I will during the exam, you guys have access to my videos where if you want to watch how to make 90 degrees, you're welcome to pause this, jump over there, take a look, and come back. Otherwise, I'm just starting making my square, which I know needs 90 degrees, and I'm using the method of striking an arc upon itself to get multiples of 60. So we get 60 and 120. And then if I bisect that second 60, I get 90 degrees. Bisect to cut in half. So at this point, I will connect this straight up. And now I have, 2 corners, 2 sides, and my next step is going to be setting my compass to my side length. I've showed my students this method lesson 3, and I really like it for keeping the page clean and for accuracy. So I don't need to measure 5 foot 6 again. I can just set my compass to my baseline. And then I'm going to swing an arc up, creating an eyebrow. And now I found my 3rd corner. And if I take my compass and I put it on that 3rd corner and strike where I know my 4th corner should be, and I go back to my 1st corner and strike that way as well, that's how I can find the 4th corner of my square. So I'm going to go ahead and connect this, and you guys might find that you need to pause regularly while following along, and that's okay, because it can take about 20 minutes, I would say, to just go through the motions and do this. And in class we're going to spend an hour and a half doing it, because it takes some people a little longer, so definitely no problem if you need to pause. The next thing it says, now that I have my square, is to label the corners A, B, C, D, starting in the bottom left and identifying clockwise. So A, B, normally we put it down here, but starting in that left corner, I'm going to go clockwise around. And that's going to become important for where I put my next activities, principles, objectives. They're going to be based off of that length. So the next sentence, the next activity, is to create an octagon that also measures 5 foot 6 side to side. So this is the method that we've been using, and what I'm going to do is just make an octagon within it. So I need to find the center of my octagon to do this, and I'm going to take the 4 sides of my square to make the 8 sides my octagon, 4 corners of my square, 8 corners. So that to do that, we just connect our diagonals. Once my diagonals are connected, I am going to set my compass from any of my 4 corners to the center where both those diagonals meet up. And now this is kind of where you can double check to see if your square is going well, because if not all 4 of your corners reach that center, something's a little bit off, and we're trying to get within a 16th here. So carry that through. And now I've created 2 more points, and I'm going to do that off of each of my corners. So I should get 2 more points. Let's use my arm. my last one C. And all my arcs are lining up pretty well. You guys are working with a 1/16 tolerance, 1 degree tolerance. So this is the point that I will explain in class, but I normally recommend that if you're not totally happy with it, you've still probably got time to not throw this one out, but maybe take another sheet of paper and just see if you can do a better square. Because if you do a good square, then the octagon's a given almost. And you're gonna have to do both of these down on the floor. So it helps to be, you know, to at least understand what's going on, and that, you know, you can fix it if you need to. But once you get past this, you know, we don't really want to change up too much more. So that was my octagon. And then the next bullet point, next sentence, is saying, construct a segmented arc above line BC that has a chord length of 5'6" and a rise of 14 inches. So here's my chord length, B to C, and it's just a happy coinkydink that my chord length is the same length as my square. It's almost intentional. At this point, you know, I like to bring up information. You guys typically put information in the top right corner, and, you know, we're trying to minimize what we're doing. So I would just put BC equals 5'6" in my top right corner, and that, you know, handles my square, it handles my chord, and it handles my octagon, all our previous tasks. So just to keep things nice and neat, but if you do AB, you know, I still get the gist. Now, the next thing that I would recommend really quickly is if you are making a segmented arc and you know that it has to go at the top because you watched the geometry review, is just quickly make sure that that's actually still 5'6". Because if you did it a different way, or you did a mistake and this ended up, you know, a little bit inside, this whole exercise is based off of 5'6". So once we finish the octagon, you know, this stops mattering as much as the outside lengths do. So mine is 5'6". I'm happy with that. And the next thing I'm gonna do to create my segmented arc is I'm going to find my 90 degrees and the center of this arc. So by now you guys have watched lesson 5, and the first thing I need is 90 degrees perpendicular in the center. So bisecting is really good for finding the center of things. And a happy byproduct of that is that I get the middle. Or rather, it's good for finding the middle, and a happy byproduct is I get 90 degrees. Now, one thing I like to point out is I go above and below, and some of you may catch on that it goes through the center of your octagon. Some people will just not do the bottom because they're like, I don't need that, I have this already here. That's assuming this is where it's supposed to be. So I always recommend just doing all the steps anyway. That way, if this is off, it still lines up well. Okay, so now that I have the center of my segmented arc, I want to go 14 inches up. Now, I don't know if you guys remember, but you can only get 12 inches on the little tickies. So 14 inches using feet and then the leftover tickies to get my inches is the same as 1 foot 2 inches. So I am going to label this X, and I'm going to measure up with my 1 up 1 foot, that's 12, and then another 2 inches, 13, 14, and that will be Y. And I'm just labeling it anything to let people know that from this point to that point is my X and Y. And then I would recommend that you connect it. Some people have caught on that they don't really need to do this. I think it helps people see if they didn't bisect something accurately, to just connect it and create a triangle or a couple more chords within the circle. Once I have my rise, now I'm just going to bisect twice. So this line is a lot smaller than this line, so I can make my compass setting a little bit smaller, and then I'm going to very carefully strike an arc above and below. And it's starting to look a little crazy here. I'm sure you guys have noticed. That's why we want to be super careful about where we connect our arcs. Above, below. Remember, I'm trying to get 90 degrees to these lines now. So I did both from Y, then I can come over to C. And before I move over to B, I'm just gonna set this down gently, so that way I don't lose track of where those little ticks are, or those arcs meeting up, because it would suck if I accidentally went to the wrong one. So, very carefully line that up. And I'm gonna carry this all the way from that arc through this arc down till I pass this vertical line. Then I'm gonna take my compass again, and I'm gonna strike an arc, and an arc. And the reason we do it the second time is to make sure everything's lining up where it should. So hopefully I did this okay. So I'm about 10 minutes into the video, something like that. And I'm going to carry it from this arc through, and they line up pretty darn good right about here. So I'm gonna just actually circle that in green, because sometimes students will go to the center of their square and that doesn't work. I want to go to where all 3 of my bisections meet up. So with that vertical first bisection, these 2 new ones that I made, that tells me where the center of my circle would be. So now I have the radius. So if I set this to any of these points, it's gonna be the same, but I'm gonna set it to Y, because it's my way of splitting if I've messed up. Oopsie. Carefully put that back on the page. And then I'm gonna strike an arc that goes all the way from B to Y to C. Done. So that's all the information that I needed for here. You can see the arc. Things are starting to look super chaotic now. Good thing we're working on the outside of the shape. And the next thing I am going to do is geometrically divide line CD into 7 equal spaces. So this is where CD is. So this is the line that must be divided. Now it's also going to be 5'6". I'm going to leave this information section alone. And we haven't done this since our first geometry lesson. But if you want to divide something equally into 7 equal parts, I'm going to pick one of these corners and I'm just going to stick with it. So in this case, I'm going to pick D, and I'm going to make any reasonable acute angle. So it doesn't really matter what you pick, but I'm going to come from that corner. And then I'm going to label 7 equal parts along it, or make 7 equal tickies. So if I am coming from D, then I have to put 0 on D, right? I don't want to come backwards. And I'm going to do half inches. So ½ inch, 1 inch, 1.5, fix that, 2 inch, 2.5, 3 inch, 3.5, and that's my 7 equal parts. So 1, 2, 3, 4, 5, 6, 7. Now this is where I would break back in my tri-square. And if this is the end of my 7 equal parts, it makes sense that I want it to line up with the end of the line that I'm trying to divide. So I will line it up in this orientation, and I will connect C to D, or not C to D, C to my 7 equal parts. And then I will butt my ruler to the bottom of my set square. Once I have it set to the bottom, I'm gonna hold that ruler down and it's gonna create a guide, and I'm not gonna move it. I am gonna move my triangle forward though till I hit my next point where I divide into 7 equal parts. And I'm gonna carry that up. And I'm gonna keep doing it. If my hand slips, that's okay. I'm gonna go back to the very first line I made at the end of both of my lines, and I'll reset from there because I would like it to be as accurate as possible. So say I get this far and my hand hiccups, I'm gonna come back over to here, set my ruler up again, hold it down nice and firm, and from there I will set up my ruler, or my set square, and continue dividing. And so that's it. another sentence, another activity done. And the more you practice this, the faster you can do it on the exam, so that you can take your time being clean, accurate, and then you get more time down on the floor for the practical. Last sentence here, but I'm going to use AB as a baseline, and I'm going to construct angle BAE. Now, what really throws students off is they're looking at everything this way the whole time, and now angle BAE, angle BAE, is going to equal 28 degrees, and this is now going to be the apex of my angle. So B to A is 0 degrees, so I need to come 28 degrees from there. If I come from B, the angle would be ABE. If I come 28 degrees off of here, that has nothing to do with B. So what I would recommend is, if you need to, you can turn the page 90 degrees, and that will help you look at it as if it was 0 degrees, and you'd go B to A to E. But I'm going to do it in its normal orientation, so those of you who can follow along. So when we want to get an uncommon angle, like 28 degrees, this is where we're going to break out our magic number. But first, I need to get as close to 28 as I can, and that would make 30 degrees. So to make 30, I need to make 60. So I'm going to strike an arc that hits angle BA. And then I'm going to use that same arc, so striking an arc upon itself, to create 60. And now I've created 60 away from BA. At which point I would bisect 0 and 60. And that gives me 30. So connecting that, I'm going to make this relatively long because I need to make sure my magic number measures onto it. And when I put out that magic number, just like everything else on this drawing, my square, my rise, it's all going to be in 3/4 of an inch scale. So I am going to measure out my magic number of 4'9" and 5/16. So 1, 2, 3, 4. I'm going to come up till 9 and then go just past it, because the next little mark here would actually be 9.5. So I'm looking for 5/16. So right in the middle of there is as close as we're going to get on this scale, and it's so minuscule it won't make too much of a difference. Next thing, once I have my magic number 4'9" and 5/16 laid out on that 30 degrees, I'm going to set my compass to it, and I'm going to strike an arc. Now if I kept going all the way around with this measurement, this radius, I would have a 360-inch circumferenced circle on my 3/4 inch scale. I don't need that, so I just made an arc. If I have a 360-inch circumference and a circle is 360 degrees, 1 inch equals 1 degree. So now I can take 30 degrees and where I meet up with that circumference, and I can measure the difference, which is 2 degrees, so 2 inches. And I like to come from up here actually. I'm going to still use my 3/4 scale, and I'm going to set 0 at 30. And with bigger, you might have to pivot, but we're also trying to get to an angle close enough that I really don't have to rely too much on these inches. So the best method for this is, find 30, and that way I only have to measure over 2 inches. I wouldn't want to have to measure 28 all the way up from here. So once I've measured 2 inches over along the arc, so not point to point, so again, if you have to kind of pivot it a little bit, that's fine. That is going to be my 28 degrees. So all I'm going to do is connect A back through that 28 degrees and label it E. And now angle B to A to E is 28 degrees. So hopefully that helps. And if you were confused about any one part, I would encourage you to go back through some of my earlier videos and take a look, so that way you can, whether it's doing a segmented arc or dividing or using the magic number to get uncommon angles, you can take a closer look at that and then come back and remake the whole shape. So hopefully that helps. And if you guys have any questions, let me know. All right, have a good day.